Hello students! In our previous video, we learnt about three limitations or demerits of Mendeleev's table. We left the video saying that the next limitation of his classification was the position of isotopes. Now can you tell me what isotopes are? Isotopes are atoms of the same element that have the same atomic number but different atomic masses. And why is this so? This is because they have the same number of protons in their nucleus but different number of neutrons. You know that an atomic number is the number of protons or electrons in the atom. And since they are same for all the isotopes of any element, their atomic number is same. While the atomic weight, which is the total of protons and neutrons, and since the number of neutrons are different in these isotopes, their masses are different. For example, hydrogen. The most known isotopes of hydrogen are normal hydrogen, deuterium, and tritium. In all the three atoms, the nucleus has one proton. However, the number of neutrons is 0, 1, and 2 respectively. Since the number of protons and electrons are same, their chemical properties are same. But since the neutrons are different, their total, that is of protons and neutrons, will be different, and thus their physical properties like mass will be different. Another example is carbon. Carbon again has three well-known isotopes: carbon-12, carbon-13, and carbon-14. Each of them has 6 protons and electrons, because as you know their atomic number is same, but they have different masses, that is one has 12, the other one 13 and 14, because the number of neutrons is different. As you can see here, carbon-12 has 6 neutrons, while carbon-13 has 7 neutrons and carbon-14 has 8. Yes, you are right. In hydrogen, 1, 2 and 3, or in carbon 12, 13 and 14 depict their masses. To sum it up, isotopes have the same chemical properties and different physical properties. Or we can say that they have same atomic number but different atomic masses. Or they have same number of protons or electrons but different number of neutrons. Now you must be thinking about how these isotopes become a major reason for the failure of Mendeleev's classification. Remember that his table had elements arranged based on atomic masses, isn't it? Yes. And therefore, according to Mendeleev's table, these isotopes should be placed in different places depending upon their masses. However, isotopes cannot be given separate places because their properties, chemical properties, are similar. Or we can say that they are just different forms of the same element. And since they are same elements, they have to be kept together. So their position was not clear from the Mendeleev's table. Also, with the discovery of heavy elements, the number of isotopes increased, and this led to confusion as to where to put them, whether separately or in the same place. Thus, Mendeleev's periodic table did not specify where and how to arrange these isotopes. Okay, the next limitation on this list is the placement of unlike elements together or some similar elements being separated. If we observe the placements of elements in Mendeleev's chart as per his pattern of atomic mass, it is very accurate until we come to the fourth period. But then after that, he misplaced some of the elements. Let us compare it with modern periodic table. If you look at the modern periodic table, on this side, we have all the metals having similar properties, while on the other side, we have all the non-metals having similar properties again. And in between these larger groups of elements, forms the one big group, transition elements. Mendeleev did not know at that time that this long bridge existed between these groups. But he did know some of the elements of this bridge, and he sometimes mistakenly grouped them differently. For example, he placed them as a group 8 that is separately on the table. To make it very clear, let me show you this. Consider periods 4 and 5 of Mendeleev table and period 4 of modern periodic table. Now place period 4 of his table above the period of the modern periodic table. Now take these group 8 elements and place them next to period 4 elements like this. Now take the period 5 elements of Mendeleev and place next to them here. So you can observe how beautifully they get along here. Just like our modern periodic table, they form a long row. So what you can say here? Yes, we can say here that transition elements were just misplaced by the Mendeleev in a separate group. Moreover, elements like copper and mercury, barium and lead have similar properties, but they are placed in different groups. On the other hand, some dissimilar elements have been placed together in the same group. For example, elements like copper, silver, and gold are placed in the same group as that of sodium and lithium, although they have dissimilar properties. So what we see here that some dissimilar elements are placed together, while some similar elements are placed separately. Of course, although there are several limitations to Mendeleev's classification, the credit for attempting such a brilliance cannot be taken away. He has to be credited for making a start that laid the foundation of modern periodic table, the modern way of classifying elements. And what is it? We will see in our next video.